Salt has shaped civilizations, moved empires, preserved food, and even started wars. But before humans ever touched a grain of it, the ocean was already filled with more salt than any place on Earth. Every wave you see carries the memory of minerals older than the continents themselves. And every drop of seawater hides a question so familiar that most people forget to ask. Why is the ocean salty? Rivers flow with fresh water. Rain is fresh. Lakes are fresh. Yet the ocean, the largest body of water on the planet, is filled with salt. How did all that salt get there, and why doesn't the sea ever lose its flavor? To understand this mystery, we need to go back, far back, to a time when Earth was young, violent, and unrecognizable. The planet was covered by volcanoes that spit out gases rich in chlorine and sulfur. When the Earth cooled, the first rains fell, not for hours or days, but for thousands of years without stopping. These ancient rains dissolved minerals from rocks, carried them into rivers, and dragged them straight into the early oceans. The water itself evaporated again and again, returning to the sky, but the minerals stayed behind. Over millions of years, this endless cycle created the salty foundation of the oceans we know today. But if rivers carry only fresh water, why does the ocean stay salty while rivers don't? The answer lies in the quiet chemistry happening beneath your feet. Every time rain falls, it dissolves tiny amounts of minerals from rocks. Sodium, calcium, magnesium, potassium, carbonates, and more. Rivers carry all these elements with them, but they don't stay there long enough to build up. Rivers are always flowing, always moving, always emptying into the sea before minerals can accumulate. The ocean, however, is different. It is the final destination. Once a mineral reaches the sea, it stays there. Water evaporates, but minerals remain. Over time, this creates a massive concentration of salt. If you could stand on the ocean floor and look up, you would see the real reason the sea never loses its saltiness. Hydrothermal vents, also known as black smokers, spew out superheated water from beneath Earth's crust. This water dissolves minerals deep underground and releases them into the ocean. At the same time, chemical reactions inside these vents remove some minerals from the water, maintaining a delicate balance. The ocean is constantly gaining minerals from rivers and vents, and constantly losing others as they bind to the seafloor. What remains in the water, especially sodium and chloride, is what we call salt. These two elements don't react much with anything else. So once they enter the sea, they stay there for hundreds of millions of years. If you were to pick up a handful of seawater and remove all the water, about 3.5% of what remains would be salt. That may seem small, but multiply it by all the oceans on Earth and you get more than 50 quadrillion tons of salt, enough to cover the entire planet in a 150-meter thick layer of pure white crystals. And yet, even with all this salt, the ocean is not becoming noticeably saltier over time. How is that possible? Because the ocean is not just a giant bucket collecting minerals. It is part of a global system. Minerals are constantly being removed by living organisms, chemical reactions, and natural deposits on the seafloor. Nature adds and removes salt so precisely that the average salinity of the ocean has remained stable for millions of years. Before we continue, here's a quick reminder. If you want to keep uncovering the hidden logic behind our planet's most fascinating mysteries, don't forget to subscribe to Curious Horizon. Every week we explore another story that changes the way you see the world. Now, let's go deeper. Literally. Imagine diving thousands of meters down into the dark, silent world where sunlight cannot reach. Here, the ocean floor cracks open, releasing boiling mineral-rich water. These hydrothermal vents pump sodium, iron, manganese, silica, sulfates, and countless other minerals into the sea. Without them, the ocean would slowly lose its saltiness. But with them, the sea maintains a natural equilibrium, balancing what rivers deliver and what the ocean loses to sediment. And what about rain? Why is rain always fresh, even though it falls from the salty ocean? Because when seawater evaporates, it leaves all its minerals behind. The sun pulls only the pure water back into the sky, forming clouds that eventually fall as fresh rain. This rain dissolves minerals from rocks once again, feeding rivers, feeding oceans, repeating the same ancient cycle without end. It is a perfect loop. Fresh water becomes salty water becomes vapor, vapor becomes fresh water again. There is another part of the story, one that connects life itself to the oceans: salt. Every organism in the sea depends on minerals dissolved in water. Some creatures use calcium to build shells. Others use magnesium or carbonates to create coral reefs. Salt is not just a flavor, it is the foundation of marine chemistry. Without it, life in the ocean would collapse. The balance of salt is so crucial that even tiny changes could alter entire ecosystems. The ocean is salty because the Earth is alive. Because rain falls, rivers flow, minerals dissolve, vents erupt, and water evaporates. Every drop of seawater is a chemical memory of everything the planet has ever been. And every wave carries the story of ancient mountains, volcanic eruptions, and the endless patience of time. The next time you taste the sea, remember, you are tasting the history of Earth itself.